Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. We have a liftoff. Liftoff on Apollo 11.
Why isn't the moon's sky blue? Imagine standing on the moon in the middle of the day. The sun is right above you, blindingly bright. But when you look up, the sky isn't blue. It's pitch black, like midnight. Why is that? And why does every planet have its own signature sky color? So, what's actually being hidden from us? Let's dig a little deeper. Before we talk about the moon, let's look at why our sky here on Earth is blue in the first place. Sunlight actually carries every color of the rainbow: red, yellow, blue, and everything in between. Now, above us, there's a massive blanket of air made of trillions of tiny, invisible particles. When sunlight hits our atmosphere, the blue light is the fidgety one. It has shorter waves and loves to bounce around, scattering in every direction. Red light, on the other hand, is calmer, with longer waves, so it travels more in a straight line. Because blue light is bouncing everywhere, no matter where you look up, your eyes catch that scattered blue. And that's why the sky looks blue. If there were no air at all, like on the moon, there would be nothing for the light to bounce off of. Sunlight would just travel straight down without scattering. The result? A sky that stays pitch black, even when the sun is at its brightest. It's simple. A blue sky needs air for the light to play tag with. Unlike Earth, which is wrapped in a thick layer of air, the moon is a near-total vacuum. Scientifically speaking, the moon does have a super-thin gas layer called an exosphere, but the gas molecules there are so few and far between that, for all practical purposes, it's just empty space. Imagine if we took a giant oxygen tank to the moon and released it. What would happen? For a brief moment, the sky above you would actually turn blue. This is because the gas we just released would start catching and scattering sunlight. But that blue view wouldn't last long. Because the moon's gravity is so weak, it can't hold onto those gas molecules. They would quickly leak out into space, and the sky would return to its deep, dark black. This is why the lunar sky is always dark. On Earth, the air is dense enough to scatter light and paint the sky. On the moon, the atmosphere is so thin that sunlight just falls straight to the surface. Even with the sun blazing overhead, you're looking into the eternal darkness of space. However, if we could travel back 3.5 to 4 billion years ago, we'd see a completely different moon. Back then, the lunar atmosphere was actually 1.5 times thicker than Mars's is today. The sky likely wasn't black, but instead looked hazy and thick. You might wonder, if the moon's gravity is too weak to hold gas, how did it ever have an atmosphere thicker than Mars? The answer lies in massive volcanic activity. Billions of years ago, the moon was alive with eruptions, spewing out enormous amounts of gas that formed a temporary atmosphere. But why didn't that gas fly away immediately? Think of a bucket with a hole in the bottom. If you pour water in slowly, it drains instantly. But if you blast water in with a high-pressure hose, the bucket stays full, even though it's leaking. That's exactly what happened to the ancient moon. The volcanoes were so active that they pumped out gas much faster than the moon's weak gravity could lose it. So, why did it disappear? Well, that atmosphere only existed as long as the volcanoes kept the faucet on. Once the volcanic activity stopped, the supply of gas ran out. Without new gas to replace what was lost, combined with the relentless solar wind sweeping the molecules away, it only took about 70 million years for the moon's atmosphere to vanish completely. It's not just the Earth and the moon. Every planet in our solar system has its own unique sky. It all depends on what's in their atmosphere. Take Mars, for example. Its atmosphere is very thin and filled with fine, rusty red dust. Because of this, the Martian sky looks pinkish or reddish-orange during the day. But at sunset, the sky actually turns blue. It's the exact opposite of Earth. The dust scatters red light far and wide, while the blue light cuts straight through, lingering close to the sun. Then there's Venus. Its atmosphere is incredibly thick, nearly 90 times denser than Earth's, and packed with sulfuric acid clouds. This creates a gloomy, yellowish-orange sky, like a never-ending twilight where sunlight struggles to reach the ground. A planet's sky color is like its fingerprint. Every world has a different story and a different composition, giving its sky a signature hue. So, it turns out our beautiful blue sky is actually a special gift from Earth's atmosphere. Without this thin layer of air, we'd be living under a scorching sun in a sky as black as the moon, the eternal darkness of outer space. From the pink, dusty skies of Mars to the gloomy yellow of Venus and the hazy atmosphere of the ancient moon, they all teach us one thing. The color of the sky is a reflection of a planet's soul. We're incredibly lucky to live on a world where the sky turns blue every morning. It's not just a view, it's a scientific miracle happening right above our heads.